Let's go to question number 78, subsets. This is medium question and a lot of somewhat. Okay, let's get into it. Given a set of distinct integers, nums, return possible subset, the power set. Note the solution set must not contain duplicate subset. Let's check with the example. Input is 1 to 3, so the 1 here, 2 here, 3 here, and then next is the length of 2, 1, 2 here, 2, 3 here, and then last is 1, 3. Also 1, 2, 3 here, and then one more interesting is empty also included. How we gonna do? All right, okay. You know the question to generate the permutation use recursion. So I gonna use recursion too, but in this case, recursion relation is a little bit weird. So in this time, I would like to implement first, and then second, I will simulation the code. I will making while the simulated. So maybe that is the better way to understanding, I believe. Okay. Let's implement. First, we need to recursion. So name is build, and we need index and array. So and then maybe I will call like this. First, we need output, right? And then build. First index is 0, and then array, and then while iteration, all of the permutation of data, it will be go into the output. When? Yeah, at the base cases. Okay, so return output here. So first base case, if I is length of nums, so out of boundary, I will put output append list A, because I would like to, we needed to decopy, not swallow. If we use swallow, and then even this list already in the output, later it changed, the item of output also changed. So that is the reason why we use the deep copy. And then next, first time is I would like to make the empty first. To generate empty, we needed to put the recursion relation first. So build is I would like to include 1 and then A. So okay, let me simulate the current status. So nums is 1, 2, 3, and then index is, this is 0, 1, 2, and then now index is here, and A is empty, out also empty, right? So now we are here. So in this case, I'd like to make this one, and to do this, first going here, I is not nums here, no, this is finally exit is 3, right? This is exit point. So this time no, so this time it recurs again, and then plus 1, so it increase 1, and then next also it increase 1. Going here, A did not change, right? And then now here, this time this is the satisfied, so we needed to execute base cases. So output append list A. Now it's append, so I have to put empty. Does this make sense? Okay, now it's time to generate the first letter. So to do this, I needed to A append nums I. So now this one is returned. So we needed to pop the system stack. So now we are here, right? So append which one? 3. And then now append, and then also we needed to recursion again, plus 1. The reason is if it's the I is that this is the, going to the infinity loop, so we needed to increase 1, right? And after finish it, we needed to pop to change another value, 1, 2, right? Okay, Now we made this one. Okay, let's simulate. Now it's nums and then going to build and then increase, and then here is now we also add this on, and the second we are able to put 3. And then next case we go back here, right? And then this one is we already do, so now we are here. Make sense? So after going back we needed to pop in the input one, right? So now we needed to add number 2 and going to next is also exit here, right? And then we are also able to add the 3 and then going to here and then 2 3 and then now here, so we put 2 3 and then go. So okay, let's check this process is okay. Typo. Okay, looks good. So sequence is first 0, nothing. Oh, 2 first, right? And then 2 3. Okay, let again. Okay, now we make the 3 and popping is the going to 2. Ah, that's right. So that is region 2 first, and then that means when you're going to 2 and then this going to here. So learning 2 and then 3 this one. They want to say. Okay, there are some mistake the simulation, but output is okay. Good. Sequence is no problem. Okay, now we got success. Okay, let's check with the complexity. Time complexity is n is 3 at that time. This one is 8. So time complexity is 2 to the n, and space complexity also 2 to the n. Thank you.